This video will be talking about zeros of polynomial functions, and we'll be utilizing synthetic division. This information and these examples come from the free OpenStax college algebra textbook, and the information for that is located within the video. You'll be able to see the website that you can go to get more information. So this corresponds to section 5.5. We're going to start by talking about the remainder theorem. So if a polynomial f of x is divided by x minus k, which is some factor, then the remainder is the value f of k. So notice here that here is your factor, right? So you have x minus k, your 0 is k, right? So if it goes in evenly, then it's a 0 of it. If not, and there's some remainder, that remainder is the value of f of k. So we have evaluated functions before, and when we evaluate functions, what we do is we plug in the value of x into all of the x's and then solve or simplify. Now what we're going to do instead is we're going to use the remainder theorem to evaluate, which means we're going to use synthetic division. So rather than plugging in the 2, you need to use synthetic division. Don't forget to check to see if you have any missing terms. So we have x to the 4th. We're missing an x cubed. So we have 0x cubed. Okay. Then we have x squared. We're missing x. So plus 0x. And then we have no x. All right, so we have 1, 0, negative 9, 0, 14. So bring down the 1. We're going to multiply 2 times 1 and get 2. Add straight down. 0 plus 2 is 2. Multiply 2 times 2 and get 4. Add straight down. We get negative 5. Multiply 2 times negative 5 is negative 10. Add straight down. We get negative 10. Multiply 2 times negative 10, we get negative 20. Add straight down, we get negative 6. Negative 6 is our remainder, but it's also the value that we get for f of 2. So f of 2 is equal to 6. So if you use synthetic division to divide, right, so here's our value of x. The remainder is the function value. Okay? So we can check that by just plugging in the 2. If we plugged in 2, we'd have 2 to the 4th minus 9 times 2 squared plus 14. So that would be 16 minus, let's see, that's 436 plus 14. So that would be negative 20 plus 14, which is negative 6. Well, that's not, oh yeah, it is what we got. I just didn't write it down right. The remainder is negative 6, and I didn't bring the negative up. So, like for a test, for example, it would be good if I checked that, right? Remember that in order to get credit on a test, you would need to use the synthetic division method because that's what it's asking you to do. But you can always check your work by using another method that you might be more familiar with, okay? All right, number 2, use the remainder theorem to find the remainder. So we're just trying to find the remainder. So we're going to divide by negative 4, nope, positive 4, right? The 0 is 4. And then we have x squared, x, and no x. So we don't need any placeholders. So we have negative 3, 6, 24. Bring down the negative 3. We multiply 4 times negative 3, and we get negative 12. We add, and we get negative 6. We multiply 4 times negative 6, we get negative 24. We add, we get 0. So the remainder is 0. Okay. There's the information for the textbook if you're interested. All right, next we have the factor theorem. So k is a 0 of f of x if and only if x minus k is a factor of f of x, which means the remainder is 0. Okay? So, given the polynomial function and one factor, use the factor theorem to find all real zeros, then write the polynomial in factored form. Okay, so first we're going to be dividing by 1, that's the 0. Okay, we're not missing any terms, so we have x cubed, x squared, x, and no x. So our coefficients are 2, -9, 13, and -6. So bring down the 2. 1 times 2 is 2. Add, we get -7. 1 times -7 is -7. Add and get 6. 1 times 6 is 6. Add and get 0. Now, since we are told in the directions that x minus 1 is a factor, then we should expect to get 0 as our remainder. If we don't get 0, then that's not a factor, which contradicts with the directions, right? So since we started with an x cubed, this is going to be an x squared, right? So if I want to write this out, I will get 2x squared minus 7x plus 6. That's what's left over, right? That's the quotient. And so now it asks us to write the polynomial in factored form and find all real zeros. Okay, so we want to try to factor and write them all in linear factors. So we're going to try to factor this again. We can try to factor by multiplying 2 times 6. So we want our product to be 12 and our sum to be the middle number, -7. So what about -4 and -3? If we multiply -4 and -3, we get a +12, and if we add them, we get a -7. So we can get 2x squared minus 4x minus 3x plus 6. So I rewrote the middle 2. I broke this up into those two using these factors. And now I'm going to factor by grouping. So 2x is in common, so if I factor that out of the first pair, I will have x minus 2 left. Bring down the negative. A 3 is in common with the next pair. If I divide those by -3, I get x minus 2. So now x minus 2 is in common, and 2x minus 3 is left over. So that's how that factors. So I have this, I have this factor, right? So it gave me 2 factors, and then I was told in the beginning that this is a factor. Notice my highest exponent is a 3, so I should expect to have 3 factors, and I have all 3. So I can write it in factored form, x minus 1, which was the given factor, and then the 2 factors that I found, x minus 2 and 2x minus 3. So there's my polynomial in factored form. And then it asks me to find all real zeros. So remember, each factor will lead to a 0. So x minus 1 equals 0. Gives me a 0 of 1. X minus 2 equals 0. Gives me a 0 of 2. And 2x minus 3 equals 0. Gives me a factor of 3/2. So there are my zeros and my factored form of the polynomial. Okay, now what happens if we're not given a factor? So in that last one, we knew what to divide by because it gave us a factor. But if it doesn't, we have to have a way to try to bump down our polynomial to where we can find all of our answers. So that is where we use the rational zero theorem. Okay, if we have a polynomial that has integer coefficients, then every rational zero of f of x has the form p over q, where p is a factor of the constant term a sub naught, and q is a factor of the leading coefficient a sub n. Okay, so what the heck does that mean? So p is a factor of the constant term a sub 0. So this, the factors of that are p. Okay, q is a factor of the leading coefficient. So that's q. Okay, so let's look in our example for number 4. We have q is always the leading coefficient, and then p is always the constant. And we're looking for factors of those. So the factors of 4 are 1, 2, and 4. Remember, that means what multiplies to get 4. So 1 times 4 and 2 times 2. Okay, what multiplies to get 8? Well, we have 1 and 8 and 2 and 4. So 1, 2, 4, and 8 are the factors of p. Okay, so now to find all possible rational zeros for the function, we want to make the fraction p over q. So we have to use each p over each q and make fractions. Also keep in mind that it's plus or minus, so it could be positive or negative. So the first p is a 1, and I'm going to put 1 over all of the q's. So it'll be 1 over 1, that's the first one, 1 over 2, and 1 over 4. Okay, so I'm going to reduce. So I'm going to have 1 over 1 is 1, 1/2, and 1/4. So those are the 3 I get from using the 1 for p. That one's done. So now I'm going to use the 2. So now I have to put 2 over each q. So I will have 2 over 1, 2 over 2, and 2 over 4. Okay, now I need to reduce those. 2 over 1 is 2. 2 over 2 is 1, but I already have 1 in my list. 2 over 4 is 1/2. I already have that on my list. Okay, now I need to use 4, so I'm going to put 4 over every q. So that's 4 over 1, 4 over 2, and 4 over 4. 4 over 1 is 4. That's not on my list yet. 4 over 2 is 2. That is on my list. 4 over 4 is 1. That's on my list. Okay, so now I'm going to use the 8. So now I need to put 8 over every q. So that's 8 over 1, 8 over 2, and 8 over 4. 8 over 1 is 8. And then 8 over 2 is 4. That's already on the list. 8 over 4 is 2. That's already on the list. So here is our list of all possible rational zeros for the function. That's all we were asked to do in this example. But if we were asked to find the actual rational zeros, not just the possible ones, what we would do is we would use the numbers on this list and do synthetic division until we found a remainder of 0. So that's what we would do. These are our choices of numbers that could possibly be zeros of the function. Okay, so number 5, this says use the rational zero theorem to find all real zeros. So we're going to have to find the possible ones like we did number 4, but then we're going to have to take the next step and go ahead and do synthetic division until we get a remainder of 0 and go from there. Okay, so let's first find the possible rational zeros. So remember that p, let's go back, p is the constant and q is the coefficient, the leading coefficient. So p is the constant, q is the leading coefficient. So think about it as working backwards. So q, our factors of q are 1 and 2. Our factors of 24, well, there's quite a few. There's 1, 2, 3, 4, 6, 8, 12, 24. Okay, so 1 times 24, 2 times 12, 3 times 8, and 4 times 6. Those are all the ways to multiply to get 24. Okay, so our possible rational zeros. So our possible rational zeros are plus or minus 1 over 1 and 1 over 2. 2 over 1 and 2 over 2, which is 1. 3 over 1 and 3 over 2. 4 over 1 and 4 over 2, which is 2. 6 over 1 and 6 over 2, which is 3. 8 over 1 and 8 over 2, which is 4. 12 over 1 and 12 over 2, which is 6. And 24 over 1 and 24 over 2, which is 12. So here is all of our possible rational zeros. Now what we have to do is we're going to have to just start picking numbers and doing synthetic division until we find one where we get a remainder of 0. I almost always start with 1 because I just feel like that's the easiest one to do, and if it happens to work, then my life is as easy as possible. So that's what I'm going to do. I'm going to start with 1. So I'm going to take, and again, you're going to use the numbers on this list to do synthetic division. You would not try like a 7 because 7 is not on the list, and it definitely will not work. The only numbers that could possibly work are the numbers on this list. So 1, I'm not missing any terms, so my coefficients are 2, 7, -10, and -24. So I'm going to bring down the 2, multiply and get 2, add and get 9. Multiply and get 9, add and get -1. Multiply and get -1, add and get -25. Okay, the remainder is not 0, so this does not work. Okay, so now I'm going to pick another number. So let's pick -1. So I have 2, 7, -10, -24. So bring down the 2, multiply and get -2, add 5. Multiply and get -5, add -15. Multiply and get 15, add and get -9. That's not 0. So again, this does not work. Okay, I'm going to pick another number. I'm going to skip the 1/2 because I'd rather not use the fraction unless I have to. So let's try the 2. Okay, so 2. I have 2, 7, -10, and -24. So bring down the 2. I'm going to multiply and get 4, add and get 11. Multiply and get 22, and then I add and get +12. Multiply and get 24, add and get 0. Okay, so yay, we found one that works. So here is a 0. We were told to find all real zeros, so here's one of them. How many zeros are we going to expect to find? Remember, you can look at your highest exponent, so we're looking for 3 zeros. So we just found one of them. Now we're going to rewrite our an equation with the new information we have from the quotient, right? So since we started with an x cubed, this is going to be x squared, x, and then no x, which is the constant. So we have 2x squared plus 11x plus 12. And now we want to either try to factor that, or we might have to use the quadratic formula or something else. Let's try to factor first. Okay, so we need something that multiplies to get 24 and adds to get 11. So 2x squared plus 8x plus 3x plus 12. So 8 times 3 is 24, and 8 plus 3 is 11, so that should work. So take out a 2x here. That'll leave us with x plus 4. Bring down the plus. The 3 is in common. That'll leave us with x plus 4. So x plus 4 and 2x plus 3 are the factored version of this 2x squared plus 11x plus 12. And remember that each of these will lead to a 0. So x plus 4 equals 0 will give us x equals -4. And 2x plus 3 equals 0 will give us 2x equals -3, divide by 2. So x equals -3/2. So there are 2 more zeros. So here's another 0, and here's another 0. So we found 3 zeros, which is what we wanted. So our 3 zeros are 2, -4, and -3/2. Okay. So the next thing we're going to talk about are complex conjugates. You should know that if a complex number is a 0, then its complex conjugate is also a 0. So if a plus bi is a 0, then a minus bi is also a 0. We can use that in an example like this. Find all zeros given the function and 1 0. So we are given the 0 of I, okay? That means its complex conjugate also has to be a 0. Well, the complex conjugate of I is negative I. So negative I is also a 0. So now we already know 2 zeros just because of the complex conjugate theorem. Now, what we're going to have to do with that is we're going to have to do synthetic division with the I. So this can be challenging sometimes, but just take your time and you'll be able to get through it. So first, let's use the I. So I'm going to be dividing by I, and I'm going to have to leave extra space between each piece because of the I. So I have a 4, 3, 2, 1, no exponent. So I've got all my terms there, not missing any. So negative 5, 25, negative 5, and 30. Hopefully I left enough space. So I'm going to start by bringing down the negative 5. When I multiply, I get negative 5i. These are not like terms, so I have negative 5 minus 5i. Okay, now I have to multiply. That means I'm distributing. So that's going to be I times negative 5 is negative 5i. And then I times negative 5i is negative 5i squared. Remember, so let's do some scratch work over here. I have I times negative 5 minus 5i. That's going to be negative 5i minus 5i squared. But remember, I squared is negative 1, so this is going to be negative 5i plus 5. So plus 5. Now, these two are like terms, so I can combine those. So I will get 30 minus 5i. So 30 minus 5i. Now I have to multiply. So I'm going to multiply I times 30 minus 5i. That's going to give me 30i minus 5i squared. Again, the I squared is negative 1. So that's going to be 30i plus 5. So 30i plus 5. So negative 5 and 5 cancel out, so I'll just have 30i. Now I'm going to have I times 30i, which is 30i squared. So that's 30 times negative 1, which is negative 30. And then that's 0. Remember, we should expect a remainder of 0 because it told us that I is a 0. Okay, so now what we have to do is we're going to use this quotient and do synthetic division with the negative I, since we haven't used the negative I yet. So we're going to have negative I with a negative 5, negative 5 minus 5i, 30 minus 5i, and 30i. Now, this one seems like it's going to be way worse, but it's actually not. This one's easier than the previous one, and you'll see why. So we bring down the negative 5. Negative 5 times negative I is 5i. Notice that these two cancel out, and we're just left with negative 5. Now, negative 5 times negative I is 5i. Again, notice that these cancel out. We're left with 30. 30 times negative I is negative 30i. These cancel out, and we have a remainder of 0. So see, that was much easier than the previous one. Okay, so now we can write this. Now let's be careful. After you do synthetic division once, we started with a 4. So after doing synthetic division the first time, this bumps down to an x cubed. But we did synthetic division on that, so now it bumps down to an x squared. Okay? So keep up with how many times you do synthetic division and bump it down each time. So the equation or the expression associated with this is going to be negative 5x squared minus 5x plus 30. Okay, and so now to find the other two zeros, we're going to have to factor that. So I can factor out a negative 5, so negative 5, and that will leave me x squared plus x minus 6. Okay, to find the zeros, I'm setting it equal to 0. And so if I divide both sides by this -5, that gets rid of that. So that'll make it a little easier. So I'll have x squared plus x minus 6 equals 0. This will factor into x plus 3 and x minus 2. And so then I'll have x plus 3 equals 0, which gives me a 0 of -3. And x minus 2 equals 0, which gives me a 0 of 2. Okay, so let's count up my zeros. I have a 0 of -3. Whoops. -3. I have a 0 of, shoot, I erased too much. I have a 0 of 2. Okay, and then I have these two zeros of I and -I. Remember, I was looking for 4 zeros, and I found them all. So my zeros are I, -3, and 2. Okay, number 7. So for this one, we're trying to find all complex solutions, real and non-real. So we want to first start by figuring out how we can tackle this. It doesn't give us a 0 or a factor or anything to use. So in that case, what we need to do is we need to try to find the possible rational zeros and use synthetic division in order to find one that works. So remember that we have P and Q. So P are the factors of the constant term, and Q consists of the factors of the coefficient. So in this case, the factors of 26 are 1, 2, 13, and 26. And the factors of 1 are, that's just 1. So P over Q is plus or minus 1, 2, 13, and 26. So in this case, when the Q is 1, your list really just consists of plus or minus the factors of P. So now what we want to do is use synthetic division to try to figure out which of these factors work. So I'm going to start with 1, and I'm going to do synthetic division. So I have 1, -8, 25, -26. Bring down the 1, multiply and get 1, add and get -7. Multiply and get -7, add and get 18, multiply and get 18, add and get -8. That remainder is not 0, which means that is not a factor. It's not a 0 of the polynomial. So we're going to go to the next one. So next I'll try -1. 1, -8, 25, -26. So I'm just choosing to start at the beginning of the list, but you can use any number from the list that you'd like. So bring down the 1, I multiply and get -1, I add and get -9. I multiply and get 9, I add and get 34. Multiply and get -34, add, that's clearly not 0, so that doesn't work. All right, next I'm going to try 2. So 2, 1, -8, 25, -26. So bring down the 1, multiply and get 2, add and get -6. Multiply and get -12, add and get 13. Multiply and get 26, add and get 0. Okay, so now we finally found a number that works. So 2 is a 0. Okay, so now we can bump this down. This is our x squared. This is our x, and that's the constant. So our quotient gives us 1x squared minus 6x plus 13. And so now we need to solve this, right? This equals 0 to figure out the other two zeros or solutions. So we could try to factor. This actually will not factor. So we're going to have to either use synthetic division again on this, or we can try to use the quadratic formula. So I'm going to go ahead and use the quadratic formula. So that means I'm going to have the opposite of b. So b, remember, so let's just quickly make a note. Remember that a is 1, that's the number in front of the x squared. B is in front of x, so that's -6, and c is the constant, which is 13. So the quadratic formula is x equals the opposite of b, so -6 is 6, plus or minus the square root of b squared minus 4ac all over 2 times a. So we'll have 6 plus or minus the square root of 36 minus 52 all over 2. So 6 plus or minus the square root of, that's -16 over 2. Remember, -16, that's going to become 4i. So this is going to be 6 plus or minus 4i over 2. And then I can divide each piece, so 3 plus or minus 2i. Okay, so find all solutions. We were expecting to get 3 solutions, 3 zeros, 3 factors, because the exponent was 3. And so I have 2, and then 3 plus 2i, and 3 minus 2i. So those are my 3 solutions. So 2, 3 plus 2i, and 3 minus 2i.